if you notice that the camera is on, so please maximize my view. Yeah, I will. If I have to, I'll switch to the computer. I'll just turn off the camera if it doesn't work. Now you see the board in front of you, right? Right? You see the board.
Yes.
Okay. Is it clear? Is the board clear for most of you? Let's say. And what I mean by clear, if I write something, let me. Now you are about, how many are you are? You're about 24, 23, 24. Okay, 24. So if I write something on the board, can you let me know if you can see? For example, I wrote in here. I wrote it before the previous class. Can you see the text? If you can see the text clearly, can you raise your hand, please?
Yeah.
Yeah, if you can read it, let's say. Okay, about half of you. Okay, well, mashallah. Okay, most of you. So I can say that maybe 80% of you. If you cannot see it, can you raise your hand? Okay, if you see it, lower your hand. If you cannot see it, I just want to make sure that the others didn't just log in and disappear. If you cannot see it, if it's not clear for you, can you raise your hand? If it's not clear. Okay, 2 of you. Is it too small? Yani, if I make it larger, would it be better? For those who couldn't see it in the previous situation, can you tell me now if it's clearer? Maybe you can open your mic. Yeah, everybody can see this now? Anybody cannot see this? Okay, looks like it's okay. Is it smooth? Now, do you see me moving smoothly? Or do you see, for example, suddenly I jump different places? The frame rate, let's say, is low. What do you think?
Smoothly, like in the class.
Okay, let me ask you this, gentlemen. Do you think that this technology is suitable or not? Assuming that you can see the text, do you think that this is a way that we can use for teaching students online? I assume that I have no one in here in front of me. By the way, I am in building 6. I don't know if you have been to building 6 or not. This is basically the auditorium of building 6. If you have never been to building 6, it's the physics. I don't know if you have been. Probably most of you have not been in here because anyway, whether you've been in here or not. So I'm in building 6. We decided to use. I decided to use this auditorium because of the fact that auditoriums are large, and clearly the university would prefer to use those because they are very wide. So you can fit, relatively speaking, large number of people in here compared to a small classroom where you can only fit maybe 10 or so students. Okay, so this is why we're deciding to use the at least to test the auditorium. Do you think that this is a suitable way, or do you think it's suboptimal? Yeah, for example, compared to the previous modes of instruction that I've the way that we have been teaching since the beginning of the semester, or even with other faculty, do you think that writing on the board like this would be suitable? You'll be able to understand, or do you think that this is better or this is worse? If you have any thought, just open your mic. No problem.
I think, Doctor, it's worse. I'll speak for myself. It's
sure.
Smooth, but the quality is not good. I can see you're writing EE207, but it's not clear if it's a function or an equation and graphs and all of that.
So, everybody else agree? Will anybody has any other opinion?
I think for me it's more attraction with you.
Oh, really?
Yes.
Yeah, you feel because you see me. It's
yes. Yes.
Who thinks that this is better? If you allow me, let me just ask. Who thinks that using the whiteboard is better than just teaching using the tablet? Okay, those are 5, 6. Who thinks that about 7, let's say. Okay, so let me. Unfortunately, I forgot to bring a pen. Anyway, about
بس ثانية. هو في ايجابيات وسلبيات طبعا، بس الايجابيات اذا في مثلا الدكتور ولا شيء ما هو متعود على سالفه التابلت ولا التابلت، يصير متعود على السبوره اكثر. فهذا هو هذا هو.
Yeah, I understand, and I agree with you. هو المشكلة إنه we don't want يعني certainly what you just mentioned is absolutely right, but we don't want also the instructor to think. يعني for example, in the previous method that I've been teaching you, I know that you can see the screen. Maybe you don't see me. Maybe some of you would like to see me, but I know that at least you can see my handwriting. حتى لو كان في delay مثلا, but I know that you can see. My fear is that instructors start teaching this way. And then, with time, by the board that I have here, relatively speaking large. In this auditorium, it's about maybe 4 meters. Not every classroom has a 4-meter board. This is number one. Number two is some instructors will write this way. They have a lot of things to write, so they will write something like this. Okay. And then the fear is that the students cannot see. And you find that, for example, after explaining a very complicated concept, at the end, you didn't understand much. Why? Because you cannot read what's on the board. And I know that, for example, from my experience, sometimes, especially if your network is not really reliable, every once in a while you see that the resolution will drop, and then it will improve maybe, and then drop, and then improve, depending on how good the resolution. At least I know when we're using the tablet, the resolution, even if it drops maybe or so, it's not going to be that bad. But with this, I think it's going to be really, really bad. If it drops, if it becomes very fuzzy, not focused or so, there's a big chance that you're not going to be able to read anything on the board. Am I wrong or am I right?
That's true, Doctor.
Okay. Who prefers the tablets rather than this board? And I saw about 7 or 8 of you. Who prefers the tablet? Where you don't see me, I fully use the tablet. Almost the same number, تقريبا 7 8. اوكي، فواضح ان كل طريقه لها محبيها ولها خلينا نقول كارهيها. طيب تفضل.
ممكن احنا ممكن ما قد جربنا الطريقه اللي تتكلم عنها الان، ولا قد شفنا طريقه الشرح عليها، فممكن ما نقدر نحدد بالضبط، يعني ما كتبت لنا قليل.
Can I use it for a few minutes? Can I use it for a few minutes? Okay. I will use it الآن to start the class. طيب نكمل الآن الوقت، راح تقريبا 12 minutes, بس I think it's useful الحقيقة. You gave me very good insight. Yeah. So what I will do is I will teach you what was the. So by the way, I haven't taught this way for a while, for more than a year now. This is why, I'm kind of forgot how. Yeah. Let me teach you using this. Okay. So if you remember, gentlemen, over the past couple of. By the way, what I will do is I may share with you also the OneNote. I think you can switch between what I'm sharing with you and my view. صح? You can either enlarge this and reduce this, or vice versa, right? I think so, right? ولا صح ولا لا؟
أعرف هذا الشيء في التيم، لكن ما أدري إذا في البلاك بورد نفس الشيء ولا.
Yeah, I think حتى في البلاك بورد. I think if you double click on my video, I think it will make it larger. It will make the sharing smaller and vice versa. But this I haven't shared anything with you. Okay, share. Okay, let me share with you. See, can you switch between what I'm sharing with you now and my video, or not? Can you switch, gentlemen, or not?
Yes, we can.
Yes,
we can. Okay. Yeah, which means when I'm explaining here, I expect you to be focused in here. When I'm gonna show you, when I'm gonna talk, for example, about the property of the Fourier transform, you will switch back to what I'm sharing. By the way, is my voice clear here?
Yes.
Yes, it is.
Okay. If you allow me just one more thing, I'll go to the back and speak, and I want you to tell me if my voice is clear or not. Maybe all the way to the end. My apologies, can you hear me now? Is it clear?
Yes.
Yes, we can.
Okay. Good. So at least the voice is okay, but maybe the video is not that good. طبعا الآن one more thing that I have to do is I need to do this. المشكلة okay. So now what I just did is because I'm connecting the projectors to the computer. I have two projectors. I have two projectors to the left, one to the left, and one to the right. So I made it kind of an extended form. So now both the people who are in here can see my computer, and you can see also what I'm sharing with you. So things now appear to be okay. So what I will do is I will just make sure that the screen, this is in the middle, okay? And let's start, okay? If you remember, gentlemen, yesterday what we did is, والله believe me, هذا يحتاج, this configuration requires, let me say it this way, sorry.
يحتاج لك مساعد يا دكتور.
Yes. This is what I was going to say. يحتاج مخرج ومنتج ويحتاج, I don't know. It's not easy to manage of this alone. It is not easy at all. I think I need to bring this in here. Yeah, okay. I think, yeah, now okay. Clear? So now I have my screen, which if I need to write in here, I can write. And you can see what I'm writing, and you can see me. صح? Okay, good. Clear? So let's start. I will, whenever I need, I want you to refer back to the projector. Yeah, I'm not the projector, I mean what I'm sharing with you. Okay? But if you remember, gentlemen, over the past last class, what we did is we solved some maybe one or two problems in which I gave you a function and asked you to find the Fourier transform. How did we find the Fourier transform? We used two tables. Let me just remind you. We used two tables. One table that we called the Fourier transform pairs. Now I'm referring back, by the way, to my screen. We used one table which is called the Fourier transform pairs, and the other table is called the Fourier transform properties. Those have a completely different job. One of them tells you if you have this function, this is Fourier transform. If you have this function, this is its Fourier transform. The other one says, well, if you don't have exactly the function that you want, but you have some function that is similar to it. Okay? For example, I have something that multiplies by the function that you know is Fourier transform. What is the Fourier transform of this modified version? Okay? So this is the difference between this table and this table. One of them tells you if you have u of t, this is its Fourier transform. If you have cosine, this is its Fourier transform. If you have sine, this is its Fourier transform, and so on. This is this table. And the other one says, well, if you have cosine but shifted, give the Fourier transform of the cosine, and then come to the shifting property here to see what is the effect of the shifting on the output Fourier transform. Okay, Akhwan? So I assume that this is clear to you. You know the difference between those two tables. Let me just erase the mess in here. Let us start. Okay. And again, I wrote some examples. Let me just see the first example here. X of t, and I tried to make my handwriting a little bit large. You can see it clearly.
Yes.
Anybody cannot see it? Okay, it looks okay. So it looks like all of you. Wallahi, believe me, it requires help. It's very difficult to manage all of those things at the same time. Abdulaziz, I think you're raising your hand. You cannot see? Well, is it previous raise? Abdulaziz Shahrani? Okay, so maybe for that. Okay. Then x of t is equal to rect of t minus 2 divided by 5 times cosine. Well, believe me, I haven't taught on the board for a while now, so it seems a little bit odd to me. Cosine 2 pi times 7 t minus. Let me start with this one. Yeah. Okay. In fact, yeah, okay. We did something similar to this before, okay? But there's no harm in doing it. طيب يا اخوان, anybody can help me? You have the table in front of you there. And let me make sure that the table contains everything that you need. Okay. This is the table that we have, okay? يا اخوان, can you look at the table and tell me, first of all, which property, which Fourier transform pair am I going to use? Let's take it step by step. Any thoughts, gentlemen? Look at the table that we have in front of us, okay? And let me know which of. I know that you probably have to switch between the table and the board in here, but do your best. What I have is a rect of a shifted version of time, scaled maybe, okay, multiplied by a cosine with a specific frequency and a time shift. Any thoughts? If you have, تفضل يا جهاد. يا جهاد تفضل.
نفس المثال المره اللي فاتت اللي هو نستخدم اللي هو التيبل اليمين صحيح اللي هو جي اوف تي وكوساين.
صح. Yes. But which property?
خاصية قبل الأخير.
اللي قبل الأخير.
I think.
Exactly. This is the same. Sorry. I was pointing at the screen. This is the thing. Sorry. I'm sorry, at the projection. Believe me, it's very confusing because I keep forgetting what you can see and what I can see. So so this is basically the property that we have to use. Okay. Sync. No, not sync. Sorry, the one above it. My apologies. Yeah. We have to use this property, which says that the rect of t divided by tau has a Fourier transform which is equal to tau multiplied by sync omega t over 2. Which means that if I have only the rect in here, let me take it one step at a time. Rect of t divided by 5, this has Fourier transform which is equal to sync, it's first of all tau, so I have tau which is equal to 5. Tau is the denominator of t, or whatever t is divided by. So this is going to be equal to 5 multiplied by sync of omega 5, or omega multiplied by 5 divided by 2. The 2 is from the formula itself. Okay? So I was able to find the Fourier transform of this to be equal to that. Now, clearly writing on the board is easier for me. It's natural compared to even writing on the tablet, but tablet is not that bad. Okay? Now, I found only part of this. Okay? So can I? What's the next step? Let's see. What do you think the next step? Should I find the shifts? Okay, or should I find the Fourier transform of the rect multiplied by the cosine? This was the reason why I want, and I gave you this. Okay, is that I wanted to show you a point here. What do you think, gentlemen? What's the next step after I found that the rect has a Fourier transform which is equal to this? حسين.
أنا عندي سؤال وإذا كان multiplication يصير convolution في ال.
Yes, you're right. إذا كان في عندنا multiplication in here, one of the properties which is this one. See this? Multiplication in time becomes convolution. But I mentioned yesterday, I think in the class yesterday, I mentioned try to avoid this. If you have multiplication in time, try to avoid converting it into convolution in frequency. And the reason is that once you convert it into convolution in frequency, it might be easy for you to say, oh, okay, I have the Fourier transform of this, I have the Fourier transform of this. Now let me find the two Fourier transforms and convolve them. Convolution is always something that you try to avoid. In fact, the upper formula, this one, the reason why we're using it is that it converts convolution in time into multiplication in frequency. So we prefer to, instead of taking convolution in time domain, okay, we prefer that we convert it into frequency domain, multiply, and then return it back, rather than doing the convolution. Think of it this way. Convolution is always something that you try to avoid, whether it's in time or in frequency. What you mentioned, Hussein, is absolutely right, However, you can do it, except that you'll end up with needing to convolve in frequency, and it's something that we don't want to do. We need to depend on other properties that will avoid us, that will allow us to avoid doing the convolution. Okay, Hassan?
Okay, great.
Okay, right? So now the question is, I have one of two options. I can either find the time delayed version of this, find its Fourier transform, okay? But the problem with doing this is that look at the formula in here where we have the cosine. Multiplication by cosine. Because eventually we'll have to find the relationship in which we multiply by cosine, which is this one. The cosine there itself, if you notice, is not shifted. And there, the cosine, let me write it on the board in here. Well, I lost where the pen is. I think this is it. Yeah. If you notice in here, let me say this way, gentlemen. We have one of two paths. Either we can say the following, rect of t minus 2 divided by 5, find its Fourier transform, whatever. Using this and using the shift in time property. Okay? And then we have to use the property which is the property that says g of t or x of t, g of t, let's say, multiplied by cosine 2 pi omega t. I'm sorry, so we've got 2 pi omega t, omega 0 t. Okay. Has the Fourier transform, which is 1 over 2, if I'm not mistaken, capital G of omega minus omega 0 plus capital G of omega plus omega 0. The problem with doing this is that this time is not shifted, isn't it? And then we cannot say this. We cannot say that we found the Fourier transform of this. So now let me just shift the time in here. Because all of this needs to be shifted. I hope that I explained to you the concept in here, Akhwan. Look, I have made sure that in here I have t minus 2 and in here t minus 2, right? The right path to do is after I find this, you say this. Let me find the Fourier transform of this. I'll come in here. And I'll say, okay, let me find the Fourier transform of rect. Let me find the Fourier transform of rect of t divided by 5 multiplied by cosine 2 pi 7 okay, t. Look, what's the difference between this one and this one? This one is shifted by 2. Let's see, is a shifted version of this, where I remove every t and replace it by t minus 2, right? So if we go from here to there, we have a property in there, which is the property number 13. So I'm pointing at the projector, okay? We have property number 13, the one that you see in front of you. And then we can use the time shift by 2 steps, okay, to come up with this. But if we go this path, okay, we have found this, that's okay. But the property that we have there does not tell us that if you multiply by cosine, a shifted version of cosine, then this is what will happen. The property that we have there, which is the multiplication by cosine, tells us what is the Fourier transform if you have your signal and you multiply it by a cosine that is not shifted. So we'll end up with something that looks like this. Now, how can we do the shift? We cannot do the shift only for one part of the signal. If we do the shift for the cosine, we have also to shift direct. You understand my point, gentlemen? Okay? So this is not the right path. Let me, from this point, and this is basically what I'm going to say. And maybe you can try it. You can try it yourself at home. Let's find now rect of t divided by 5 multiplied by cosine. Cosine, what is it? Cosine 2 pi 7 t. Okay? Let me find the Fourier transform of this. And now we have to use this property, which is the multiplication by cosine, which is this. Okay, the property number 13. the property in the second table that is equal to number 13. If you multiply by cosine, we know that you shift to the right and shift to the left. And divide by 2, 1 over 2. The Fourier transform that I got for this is this. So I'll get 5, I can take it out, and it will be equal to sink omega 5 divided by 2, omega minus omega 0. And omega 0 is equal to this omega 0. This omega 0. So it will become equal to 5 multiplied 5 is inside, multiplied by omega minus 7, 2 pi times 7, 14 pi. I don't know why I like number 7. So this is the first term, plus shifted also the same thing, but shifted to the other side. So I'll get sink of 5 multiplied by omega plus 14 pi divided by 2. Okay? So this is basically the Fourier transform of this. Now the last step is remove every t from everywhere. Wherever you see t, it's not, you cannot just shift the cosine by 2 or shift this by 2 and say that this will result in multiplying by e to the power of something. Okay? Yeah, you cannot use this property, which is property number in here, this one. Property number 7. Yeah? You cannot use property number 7, gentlemen, unless all of the functions are shifted. And I promise, inshallah, I'll give you, how much time do I have? I'll give you, inshallah, maybe not next example, the example after that, an example in which I will show you what happens if they are shifted by different amounts. Yeah? You can play with it so that you can put it in an appropriate way. Okay, Juan? So this and this have to be shifted so that you can use that property. It's not, you know, if this was not shifted, you cannot use that property. Is it clear, Juan? Gentlemen, is this point clear? If you want to use the shift property, every t has to be removed and replaced by t minus 3 or t minus 7 or whatever. The same shift in the whole function. So t minus 2. So now I'll have to find the rate. T minus 2 divided by 5 multiplied by cosine 2 pi times 7 multiplied by t minus 2. We'll have the Fourier transform, which is exactly the same as this, multiplied by, what does the formula say? It says multiplied by e to the power of minus j omega t0. Multiplied by e to the power of minus j omega, and t0 is basically the amount of shift without the minus. So this is basically the result. So I gave you this example because of this, this idea. I wanted just to make sure that you understand this idea whenever you have time shift or other transformations. Any questions so far? How good is this method so far? I mean, how good is the explanation so far? Is it okay, or do you want me to switch to the tablet? Both ways are okay.
The tablet, it is easier to read for yes.
Everybody agrees, or most of you agree on this? If you agree, raise your hand so that I. About 10 of you. Like, who doesn't agree? Who thinks that this is better? تصويت يا اخوان. اليوم صاير ديمقراطي. Who thinks that this method is better? يعني you prefer that I continue this way? And I just wanted to experiment. I just wanted to do it to make sure that whether it works or not. And I think I got good. Okay, احمد الحبردي وعبد العزيز ظهر رافع يد من زمان. بس ظهر احمد you're the only one. So my apologies for this. It looks like I'll have to switch. Okay.
هو يا دكتور جوا السنك انت كاتب ارقام فتبدا تصير صغيره ما تبان في
الصف. Yeah, I know. And I'll tell you something. I told you, I think, in the past that whenever I use a tablet, I always start, whenever I solve a problem, I always start with small font. Very often, if the problem is long, by the time I reach the end of the problem, the font becomes larger. I don't know why. I noticed that whenever I use the tablet, this happens. On the board, it looks like it's the opposite. You start with large font, and by the time you reach the end, تصغر الأشياء. Maybe because I get squeezed. The tablet does not have limits. while on the board I start to feel that I'm kind of squeezed at the end, so I reduce the font لا شعوريا يعني without feeling it. I know that the board probably is going to cause problems, and I was thinking that the tablet is the best option. But you know what this means? This means that maybe the university will have to invest maybe 5 million riyals or so to buy tablets for all of the faculty. And I'm not sure that all of the
في فكرة لكنها يعني تكلف الصراحة، اللي هي ان انت في نفس الكلاس روم تقدر تكتب على التابلت في البروجيكتورز.
قصدك سمارت بروجيكتورز؟
لا انت عندك التابلت يصير في ناس في الاونلاين، في ناس في الكلاس روم. اللي في الكلاس روم ينظرون اللي تكتب على البروجيكتور نفسه زي ما انت مسوي الحين على البروجيكتور.
يا اوكي، يعني قصدك الفيديو is of projection something like this.
لا انت حاليا مسوي شير السكرين على البروجيكتور اللي عليك صح؟ على اليمين وعلى اليسار
صح. يس
فانت تصير نورمالي كانك في البيت تكتب على التابلت، فاللي حاضرين معاك يصيرون ينظرون في البروجيكتور اللي على يمينك وعلى يسارك كان سبوره ما لها داعي.
This is the idea that I was proposing. هذا معناه ان كل faculty has to have his own tablet. والبوينت انه كان فيه اقتراح هل نشتري تابلت لكل غرفه ولا نشتري تابلت لكل كلاس روم. طبعا if you buy it for classrooms عدد الكلاس رومز اقل. بس ايش قالوا الاساتذه او ايش كان الكونسيرن؟ ان هذا معناه ان if I have corona I'm using the tablet الان، التابلت ملوث، يجي الاستاذ اللي بعدي يستخدم التابلت يصاب. You get the point? So most likely if they're going to be doing the tablet option, every faculty will have to have a tablet. هي الجامعه I don't know for some reason يعني الجامعه على فكره تعطينا احنا كمبيوترات، بس I don't know why they don't like tablets. They don't like anything in which they have that standard type of computers which are very dull very inefficient very inconvenient. خلينا نقول maybe they need to switch الآن to more sophisticated devices. بس على العموم يعني it looks like the university is really seriously thinking of going this path. Okay, بس لحد الآن as I told you يعني once the university decides إن this is the best way of going, well, خلاص this is the way that teaching will happen next semester. It looks like they may buy tablets. It depends. Okay, good. So I will switch to the tablet. I'll turn off the camera. خلوني let me just figure out what I have in there. Okay, bring this in here.
أنا طبعا لو هو في رأيي شوف ما نرجع حضوري إلا إذا رجع الوضع طبيعي وشلنا كل الكمامات أصلا في رأيي يعني.
ولكن صح كلامك صحيح yes. Okay, but when will this happen? يعني you remember when the corona started في March last year. Honestly أنا لما الجامعة قالت في البداية إن أوكي أسبوعين الطلاب ما راح يجوا، أوكي قلت أوكي أسبوعين يمكن تزيد 3 أسابيع. لما الجامعة بعدها تقريبا بشهر ولا كذا قالت let's extend it to the end of the semester, my first instinct was what who thought of this? إن شاء الله كلها شهر we're gonna come back يعني شهر ولا شهر ونص we're gonna come back. They went and cancelled the final exams if you remember in that semester. Right? Until now we're more than a year and a half. Things are better, but clearly they're not much better. You never know when we'll be able to come back. Yes, I know and it's a concern. انتم ما شاء الله عليكم شباب يعني probably لا قدر الله لو اصيب احد منكم his health is going to be able يعني he's probably going to be able he's going to survive without much problem. احنا الاساتذه اللي بعضنا يعني عمره 60 70 احنا we're the ones who are really in risk. طيب يلا الله يعين. بس I understand your concern and I think it's a valid concern. طيب let me just hide this. Okay, what do I need to do? Let me go to okay. So now you see my screen, صح? And let me just turn off the video. All right. Okay, Juan, you see my screen, right?
Yeah.
Okay. طيب طبعا خلاص I turned off the projector. The projection is no longer there, but we don't need it anymore. طيب let me what did I do? Now let me give you another example. Okay? And this is going to be, this will be inshallah kind of maybe how do I say it? Maybe a little bit fun. Okay? Okay? This is the next example. Again, we're going to try to find the Fourier transform of the next of this function, where x of t is equal to r of t minus r of t minus 2. Okay? Now, if you plot this function, by the way, this is how it will look like. I hope now that you are experts in plotting functions like this. This is how the signal will look like. R of t in here, and then at 2, it becomes flat. Okay? Now, how do we find the Fourier transform of this? This is fun, but this will give you good insight on how you find the Fourier transform of specific functions. And I can tell you that this table will allow us to find this. This table, although it's a little bit, let me just move it. This table will allow us to find the Fourier transform of that. We have enough information. This is basically what I'm saying. Any thoughts, gentlemen? What do you think? Look at the table and tell me, what are the functions that I can use from the left table or the right table? Yeah. I cannot see who's raising his hand. If you have any thought, just say it.
First property عشان الجمع صح؟ يصير الأولى فورير ترانسفورم لحاله والثانية فورير ترانسفورم لحاله.
Good. Okay. What you said is absolutely right. Yes. So this one. صح? But this doesn't help that much. Do you see R of t in there? Look at the table. Do you see R of t in here in the left table?
No, what's U of t?
For U of t, yes. For impulse, this R of t is now there. So are we stuck? No, we're not stuck. طيب,
نحولها تي يو اوف تي صحيح؟
Well, you can do it this way. Yes, you can do it this way. Let me see. Do we have? In fact, we have. Okay, what you said. Whoever answered this, yes, this is part of it. You see this? But again, I was thinking of it in a completely different way. This will help us. We can use this where a is equal to 1. You see this property? We can set a to be equal to 1. I'm sorry, 0. A equal to 0 in here. Sorry, the font here is quite thick. We can set a to be equal to 0. Okay. So this basically disappears. This becomes equal to 1. And we'll end up with t to the power of n u of t. Yes, this is one way of doing it. Okay. Where n is equal to 1. Basically, we'll end up with 1 factorial, which is equal to 1, divided by a is equal to 0. So j omega raised to the power of 2, isn't it? Something like this. N is equal to 1. This is one way of doing it. Now, طبعا for the other one, where is it? For the other one in here, r of t minus 2, we'll have to write it as t minus 2 multiplied by u of t minus 2. And we'll have to use some, in fact, we already found the Fourier transform of this. This is a shifted version of it. So we'll have to use that multiplication by e, which is this. When you shift in time, you multiply by e. This will do it, but there is another way of doing it. Completely different way. Anybody can think?
I think we can write r of t as simply y equals x. I mean, just a line.
Y is equal to x. لا, but r of t, no, r of t is not equal to t.
Yes, it's not
t
equal.
extends like this from minus infinity to infinity, but r is equal to 0, and then it changes. It becomes, it increases. صح?
Yes, but we limit the integration.
لا بس الفورمولا اللي موجود عندنا هنا يعني I don't see how this will exactly help us. لأن حتى لو كان عندنا احنا t, لو يعني for what you proposed is that if we had something like the integration of t, something like this, I think, or عفوا يعني I would agree with you if we had even the Fourier transform of t, but I don't see the Fourier transform of t there. We have the Fourier transform. Which one?
We do it formally. I mean, by the definition.
You use the formula. You use the formula. Yes. The problem is that yes, for sure you can find this by integrating. Yes. The problem is that you'll have to integrate by parts. صح؟ لأن you're going to get t multiplied by e to the power of minus j omega t dt. صح? Integrated from 0 to infinity. Yes, if you do it this way, I don't have a problem. But then I'm trying to avoid doing integrations. If you notice, all of the examples that I gave you, I never had to integrate. I just used the properties, the left table and the right table. صح?
ايوه صحيح.
And I want also to continue this. يعني, let me say this way. If you're stuck, if you cannot find a solution, and this is your only option to integrate, go and integrate if you can do the integration. But clearly, if you can't use the tables, I would prefer that you use the tables. Now, I do not know who's raising his hand. Let me see who's raising his hand. Okay. I still see Abdulaziz. Abdulaziz, you're still raising your hand. Are you there? You have a question?
Yes,
ولا...
دكتور.
تفضل حسين. Yes. You're saying, right?
نطرح ونجمع اثنين او اثنين في يونت ستيب. يعني نطرح
لا. How does this help you?
يصير عندنا صفر.
لا 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 ما يطلع. كيف يطلع عندك صفر؟ لأن those are two different ramps. They're ramp functions that happen at different times. Look, this is the function. The function is not zero. If you subtract and you got 0, this means, yeah, oh, let me say this way. If it was r of t minus r of t, yes, you'll get 0. In this situation, the Fourier transform of 0 is 0. But those are two shifted versions of ramps. Or maybe I didn't understand your point.
أنا أجمع صفر. حجمع plus 2 unit step.
How does this help you? Okay.
وحطرح 2 unit step.
I do not see how this can help you. And you'll add in here 2 unit steps, 2u, something like u of t, okay, plus u, or minus u, something like this. How does this help you?
ايوه هاخذ الفاكتور ال2 مع التي واليونت ستيب مع اليونت ستيب. يعني هاخذ كومن فاكتور تي ماينس 2 مضروبه في ار اوف تي ماينس 2.
والله I see يا حسين انك كانك عقدت الموضوع. You didn't make it simpler. I think you have made it more complicated, and this is my personal opinion, but I don't know. Or maybe I didn't understand exactly your concept. And I can see the concept of adding and subtracting so that you don't change anything, but I think that adding u's in there will make it more complicated because now you'll end up with more sophisticated form, I think. Let me solve it for you using a completely different way. Now we have r of t, but we know that when we differentiate r of t, what do we get? What do we get when we differentiate r of t?
Yeah.
u of t.
صح. Okay. So if we say the following, d by dt of x of t, what is it going to be equal to? It will be equal to u of t minus u of t minus 2. صح? Can we find the Fourier transform of this part in here? And the answer is yes. We can find the Fourier transform of this. Okay? In fact, this will have a Fourier transform which is straightforward from the table here. Where is the u? It's equal to this twice. One of them is shifted by time. So it will become equal to pi delta of omega, I think. Hold on. Delta of omega plus 1 over j omega. This is due to the first step. The second step is subtracted, so minus, let me open parentheses, pi delta of omega minus u of, I'm sorry, not minus u, minus 1 over, plus 1 over j omega. But because it's a shifted version of the step by 2, I have to use this property again, which is the shift in time. So I have to multiply only the second part by e to the power of minus j omega t0. Multiplied by e to the power of minus j omega multiplied by 2. Shift is 2. صح? But I didn't find the Fourier transform of the original signal. I found the Fourier transform of the derivative of the signal, isn't it? What happens if I integrate this? Yeah, think of this, call it y of t. Yeah. What I found is I found capital Y of omega.
Doctor, shouldn't be -2?
-2. Where is -2? When -2?
The shift.
Oh yeah, the shift e to the power of minus. لا, it should be +2, and the minus is from the formula itself. Now remember,
Okay.
the formula, what does it say? The formula says that if you have g of t minus t0, so t0 in this situation is the 2. صح؟ لأن we have t minus 2. So t0 itself is positive. It's equal to 2. Right?
Okay.
Is it clear? Okay. So no, I think it is okay. But thank you for pointing this out. I thought maybe I made a mistake. Yeah. Let me just remove this. Okay. So we have a minus sign here. Right? Now what I found, gentlemen, is I found the Fourier transform of the derivative of x, which let me call it y of t. So I found y of omega. Now we know that x of t, basically y of t, x of t has to be equal to the integration from -infinity to t of x of tau, let's say d tau, something like this. Yani if I know that y is the derivative of x, then x is the integration of, this has to be y. Then x has to be equal to the integration of y. Since I'm integrating y and I have the Fourier transform of y, I need to go now to this formula, which basically says that the Fourier transform of the integration of the function is equal to the Fourier transform of the original function without the integration divided by j omega, add to it pi multiplied by g of 0 delta of omega. So I need to take all of this now. Sorry, I have very short memory, so let me show both. Yeah, I need to have the formula. So this will have now a Fourier transform which will look like this. Pi multiplied by delta of omega. I'm just writing g of omega, or let's say x of omega. Y of omega, I'm sorry, y of omega. G delta of omega plus 1 over j omega minus pi delta of omega plus 1 over j omega multiplied by e to the power of minus j 2 omega. This is simply this part in here. This. I have to divide the whole by j omega. From the formula itself. From this formula. And I have to add to it pi multiplied by g evaluated at 0. Let me just evaluate this g at 0. When you evaluate it at 0, okay, you'll end up with, okay, in here we're going to have a problem. Maybe I didn't write it properly, okay? Because when you evaluate it at 0, this becomes equal to infinity. Is it infinity? Yes. Delta of 0 is going to be equal to infinity, and this is going to be equal to 0. Let me see. I think I'm just thinking aloud. Let's say delta of omega in here. Maybe I didn't think about it. Maybe I should have. Maybe I should have given you maybe a slightly different formula for it. And again, I wrote the problems, but I didn't solve them. I just prepared for the problems, but I did not solve them. So I just noticed this, and it's embarrassing when you notice that you have a problem in here that you cannot solve. How do we solve this? Delta of 0 is going to be equal to omega, infinity. I'm sorry, right? Say again, sorry.
I think my ways will do the transfer.
Say again. I didn't hear you. What did you say?
أنا قاعد أقول أظن لو جمعنا 2 يو ونقصنا 2 يو أظن حتزبط. شيء نسوي نجمعهم مع بعض.
I'll come to your suggestion, but let me just figure out how to solve the problem that I'm facing with my method, which is the method that I thought will allow us to find the. تفضل يا
يبدو لي ما راح تجي عندنا ماينس انفينيتي، لان احنا عندنا في الاساس يو اوف تي، فبيكون زيرو المفروض.
U of t. لا بس احنا we're talking about the Fourier transform here. We're not talking about the Fourier transform sometimes of a function that is finite, let's say, that is limited between -1 and 1 or between 0 and 1. You could have sometimes points at which the Fourier transform is equal to infinity. And this is basically what's happening here. The function itself is either 0 or 1, but yet its Fourier transform, when we divide it by when we try to evaluate it at 0 will result in infinity. I promise you, I'll tell you something. Let me sort this out. I'm not sure how we will figure it out, but honestly, the idea when I put this, I wanted to show you what are some of the techniques in which you can use other properties in here, not only the multiplication by cosine, the multiplication by sine, but can we use maybe some of the properties in which we integrate or we differentiate and so on. Okay, this is basically my idea. Let me see, did I do it correctly? Maybe I x of t, I'm differentiating in there. Let me just give me a minute. Let me just see. Okay, I have g of omega. I have its Fourier transform. Yeah, I think the process that I did is okay. It's just that I needed to figure out what, if the function did not equal to infinity at omega equal to 0, I would be okay. But the function itself, this function is equal to infinity. When you plug in here 0, it becomes equal to infinity. So this is basically the problem that I'm facing. Okay, but anyway, I will resolve it for you later. I promise, inshallah. Let me think about it, and I will resolve it for you later. Fadal Abdurrahman.
Maybe we can use L'Hopital's rule and take the limits.
I was thinking of it, but you see the denominator here, you can use L'Hopital's rule if you end up with infinity over infinity or 0 over 0. But this will give us infinity over 0. صح? I don't think you can use. So it's in fact not only infinity, it's like infinity squared. Yeah, the numerator is infinity, the denominator is 0. In fact, we have a lot of zeros in here. We have a lot of infinities. Even the second term in here, you see, this will also result in infinity. This will result in infinity. This will result in infinity. All of those. So we have a lot of infinities. Let me just see. E to the power of just 1 minute. 1 minute. I think an idea came to my mind. Okay, I think I figured it out. Honestly, it just came to me, not because I'm smart or anything like this. I don't know. Subhanallah, Jani Ilham. I'll just show you what is my thoughts. You see this? This is in fact what brought it to me. Can we split it into e to the power of minus j omega multiplied by e to the power of minus j omega? Okay? And let me take a common factor. I think this will resolve the issue. Let me take a common factor outside, which is e to the power of minus j omega from the whole numerator. All right. By the way, I'm not done with the whole thing. All I did is this divided by j omega. I also have. Okay, sorry for that. This is okay in here. This part is okay. Let me just organize my thoughts. My apologies for this. This part is okay. What I need to do now is I need to add to it the second part, which is causing the problem. What is the second part? It's this. Hold on, I'm trying to erase. This is the part that is causing the problem. The first part is okay. The first part, gentlemen, is okay. We don't have a problem with it. It's for all values of omega. Now, at omega equal to 0, we may have a problem, but for other values of omega, we're okay. Now, the problem that was causing the issue, or let's say the term that was causing the issue is this term. Let me put it there because I didn't put it. That term says plus pi multiplied by all of this evaluated at 0. So multiplied by g of 0, which is all of this. Let me write it this way. Pi multiplied by pi delta of 0 plus 1 over j. let me write it this way maybe. Delta of omega 1 over j omega. At the end, I'll write that I'm substituting at omega equal to 0 minus all of this pi delta of omega. Just wait for a minute and you'll see basically what I'm trying to do. 1 over j omega multiplied by e to the power of minus j 2 omega, and I'm evaluating at omega equal to 0, okay? Over the whole thing with the j omega in here, divided by j omega, and I'm evaluating the whole thing at omega equal to 0, multiplied by delta of omega, I think, right? This is, I think, before. Yes, this is it, okay? Now I'll show you the trick. I don't have a problem with this because this is for any value of omega. Just plug in, you're going to get whatever term it will provide you.
Why is it divided?
Why is it divided by what? By the j omega? You're right. Yes, I don't have. Yeah, you're right. You're right. هذا ينطبق عليه المثل اليوم كل ما جيت اكحلها عميتها زي ما يقولون. Yes, it's not divided. And because it's not divided, in fact, Allah يخليك, who said this comment, عبد الرحمن, or who said this comment, gentlemen? Anyway, كنت معتمد على الجي اوميجا. انا كنت معتمد على الجي اوميجا. انت الان لخبطت الدنيا. What I was going to do is I was going to take an e to the power of j omega outside, or e to the power of minus j omega outside, فبيظهر عندي هنا مضروبه في e to the power of minus j omega, وهذه one of them will disappear. يعني I'll take one of them outside in here, okay? فبيظهر عندي e to the power of minus j omega in here, or e to the power of plus j omega, or e to the power of minus j omega divided by j omega. كنت راح اقول it's equal to sinc sine divided by sine x divided by x, okay? So I was going to try to figure out a way where I'm going to try to resolve it. But okay, I'll tell you something. I promise you, I'll figure this out. Forget about it. I just made a mess there. My apologies. The time is over. So I'll figure it out. الآن يا أخوان, just before you leave, we that there will be a quiz on Wednesday. And الحقيقة شفت كثار منكم, they were complaining about the time on Wednesday. What is a suitable time for you on Wednesday? الساعة 7 ما هو مناسب? If it's not suitable for you, please let me know. We need to set it up. الساعة 7 يا أخوان. أحد عنده complaint about it? Please speak up. If you have a complaint, please speak up.
Yes, doctor. It's not suitable.
طيب بعد الساعة 7 خلينا نقول مثلا 8. Is it okay?
It's okay for me.
8. Anybody
Me
has
too.
a problem with 8? Anybody has a problem with 8? If you have a problem with 8, let me know. Anybody يا اخوان? Better, I see your microphone on. Are you saying something? ولا احد يا اخوان منكم?
7:30 is not good, doctor.
7:30 will be fine with me, بس يعني حبيت اغير شويه by 1 hour عشان اضمن اذا في احد منكم عنده مشكله مثلا الساعه 7, 1 hour later probably will resolve the issue. 7:30 would be okay.
I think it's better 7:30. 7.
7:30 you mean?
Yes.
صح؟
7:30.
7:30 يا اخوان. احد عنده مشكله 7:30؟ يا اخوان احد, I just want to make sure, احد منكم عنده مشكله الساعه 7:30؟ And I hope that يعني all of you are hearing me and you don't have a problem. ما يجيني بعدين احد يقول لي والله انا كان عندي شيء وانا ما سمعته كله. 7:30 is okay, it looks right. خلاص, let's set it to be 7:30. خلاص 7:30. So our quiz ان شاء الله will be 7:30. Okay. So on Wednesday يا اخوان طبعا okay. Tomorrow I'm not going to be available. Tomorrow I'm not going to be here. I will try to record the lecture where inshallah I'll try to resolve this. Okay. I don't expect you to watch it tomorrow, and maybe I'm not even going to be able to record it tonight الحقيقة. لأن tomorrow what's happening is I'll have to travel to Riyadh. My wife has an appointment في مستشفى الملك فيصل تخصصي, So I'll go in the morning and come in the afternoon. So I'm clear I cannot teach you. And hopefully maybe later today I will be able to record the lecture. Whether you watch it tomorrow, watch it later, it's okay. It's just going to be solving some problems related to this topic. So what I'm going to do is I'm going to just solve problems related to finding Fourier transform. Okay يا اخوان؟ طيب تفضل عبد الرحمن. You have a question?
بالنسبة للماتيريال بيكون متحدد من وين لوين؟
Yeah, I'll just give you a function and ask you to find its Fourier transform, not using tables or anything like this. Just integrate it. Very simple. Okay?
Okay.
A function in which you can integrate. Right?
Okay.
Yeah, find its Fourier transform using the Fourier transform integration. Honestly, I just want to give you a quiz, to be honest. Well, I don't want to give you material like the material that I'm working on now. Then it requires a lot of practice. So I'll just give you a function, ask you to find the Fourier transform of the signal. One with the two functions maybe, okay? And just ask you to find their Fourier transform. Okay? طيب يا اخوان?
Okay, good.
Okay. So inshallah it will be easy. Especially that effectively that quiz is going to be in your vacation. And once you're finished the classes, it will be vacation. But طبعا I will give you at least half of the class in the morning as a regular class يا اخوان. Okay? ففي الصباح I'll give you a regular class. We'll take the quiz at night. خلاص. If you don't have anything, I'll see you inshallah tomorrow. Not tomorrow, after tomorrow. اوكي تفضل فيصل فيرست.
انا كان عندي ارسلت لك ايميل يوم السبت، ما ادري اذا طلعت عليه ولا لا. كلمتك امس لكن كنت انشغلت في التيمز، ارسلت لك رساله.
خلاص I'll check it ان شاء الله. Just give me a few minutes or so when I go to the class from building 6 ان شاء الله I'll check it. Okay?
تمام، شكرا لك.
Okay? And remind me maybe through a WhatsApp message or so. Okay? Just to make sure. لأن الحقيقة بالي مشغول ب 100 things honestly. But maybe if you can just remind me with a WhatsApp message or so, إن شاء الله I'll check.
أبشر.
Okay? شكرا جزيلا. شكرا. Any other comment or?
دكتور لو بس الله يكرمك تقدر تحدث نوته.
إن شاء الله. My apologies. Yes.
والله أدري إنك مشغول.
لا. It is your right. It is your right. إن شاء الله. I will إن شاء الله update. Okay. هو والله أحلف لك بالله إنه والله صار لي الآن أسبوع تقريبا من بدأت هذه شغلة إن try different technologies and so on. والله I'm so busy. لا believe me. أمس جيت أنا مع أحد زملائي إلى مبنى 59 to do some experimentation في الليل بعد المغرب. والله ما رجعنا من الجامعة للساعة 12 نص الليل. وأنا بعد ساكن برا يعني على بعد تقريبا ربع ساعة و I had to write an email immediately after that. فوالله ما نمت إلا الساعة تقريبا 1. I was so occupied. و most likely also today. وبكرة أنا بكون سايق تقريبا 8 ساعات 4 ساعات رياض و4 ساعات راجع. I'm so occupied. But yes, you deserve to have the notes updated. I'll do my best إن شاء الله to على الأقل عندي أنا I have already done some updates. فإن شاء الله I'll update the lecture note إن شاء الله.
والله يا دكتور لك ما لنا لك إلا الدعاء والله.
لا الله يخليك. شكرا جزيلا إبراهيم. شكرا. I appreciate دعوتك هذه وشكرا. بس إن شاء الله I promise you that I'll do my best.
فقط يعني اللي حدثته ما يكون يعني تكتبه أو شيء يعني يكلف عليك زيادة يعني فقط الموجود.
لا إن شاء الله. I'll do it. خلاص. حياك الله. Any other comments, gentlemen? Questions?